Hello everyone and welcome back. So in this one we are going to be building an Agentic RAG app, and this RAG app is going to be using, or we will be building an MCP server, right? These two will be connected. We are going to be connecting these two. So we are going to be building this application end to end. To give a gist of it, what this application does is the following. So here we are inside Cursor, right? We are inside Cursor and we have our code written out everywhere, and our MCP server is also running. So if you go inside and go to MCP, the server currently is running and it has a couple of tools, right? One tool is an F1 FAQ search. Any question you ask about F1 races, it will look up at that particular vector DB for F1 races and will be able to answer such questions. It also has a web search tool, right? So we have two tools available to the MCP RAG app. Now we can ask it questions. Say, who governs F1? Alright, so this is a question about F1, and if I am asking this question, I would expect the MCP client right now, so it is asking for our approval to use this particular tool, F1 FAQ search tool, which we have made it available through this particular MCP server, right? I am going to accept this, and it will use that tool to generate the answer for that question. So this is the answer, right? Now if I am going to be asking some other general question, so what is the status of IPL 2025? So this question cannot be answered using the FAQ search, right? It's not related to F1 races, right? So I'm going to be asking this question now. Instead, it's going to be using another web search tool, which is going to be used based on bright data, and it's asking us for the permission. So I'm going to accept this, and it's going to hit the internet, get the results from there. So currently unable to access real-time web search results for the latest updates. However, as of now, there has been no official announcement regarding the, okay, so this is the actual result. So how is this different from a regular RAG app? Is something like this. So you are asking a query. As a user, you are asking a particular query, right? This query is being sent to the MCP client. The MCP client that we are currently using is Cursor, right? Cursor, and Cursor, it determines if the question that we are asking is based on the F1, which is the topic that we are dealing with, if it is based on F1 or not. So if it is going to be based on F1, then it's going to look up the vector database where we have stored question answer pairs about the F1 races. And if it is not about F1, it's going to request the search tool, which is going to be based on the bright data search tool. There are so many other search tools. We just are choosing to use bright data in this case. You can also use Tavily. You can also use several other servers like Serper Search. Many other services are there. You can use whichever search tool you want to use. So in this one, we are using bright data, and this is going to look up the internet and give us back the result, based on whichever the question is for the original user query. Now here in this entire flow, there's a decision point involved, and this is the key, where it is checking what the question, the user's question, what is the topic of that particular question, and the decision of whether to use or divert that question to retrieve more context from the vector database, or should I use the search tool to get the information from the internet. That decision is involved here. So I hope this is clear. Now in order to build that out, we need a few things. First, we will need a vector DB, and this vector DB, we are going to be using the quadrant vector DB. You can use a vector DB of your choice. There's no holding that you need to use only quadrant. Likewise, the search tool we spoke about, we are going to be using bright data. You will need to make an account with bright data, create a free account and get the username and password. We are going to be setting up an MCP server. We will need an MCP client. You can use the most popular MCP client is either Claude Desktop, or we can use Cursor. For this particular example, I am going to be using Cursor. And IDE, typically you can use either VS Code, or since we are going to be using Cursor, we can use Cursor as the IDE also. So this also we are going to be using Cursor. So the first thing that we are going to do is to start a Docker container to start running the vector database. So open up your terminal. You can open it up by going to View and then click on Terminal. This is happening on Cursor, alright. So go here and you can get the command to start the container from the readme file. Alright, you can go to the readme file, and here you can get the Docker command. Just copy this and paste it in your terminal. So here I'm already inside the project folder right now. So cd to that folder, and from here run the Docker command to spin up the vector database. Alright, so here I'm running this. So this has started the vector database using Quadrant. Now let's go over the code to sort of start running the RAG app. In the project directory, you will find two different files, rag2.ipynb and rag2.py. So both are same versions. We are going to be using the Python notebook, that is Jupyter notebook, in order to execute this. So open up ipynb file. So this is the rag2 app, and let me bring down the Docker. Now before we start running the code, look at the requirements.txt. This requires the llama index quadrant client, llama index from the HuggingFace embeddings. This is the embeddings that we are going to be using for converting the query and Q&A text to vector embeddings. We also need these packages in order for the code to run completely, right? And MCP CLI is for starting the MCP server. .env is to hold the credentials or the username and password for your write data. Hold on for some time, we will come to that. Now this project is based on UV, so you will have the project.toml file. This will contain the dependencies. So first, in order for you to run all the code present in this particular project, you might have to install the packages first. And in order to install that, you can go to your command prompt. I've closed it. You need to go to the terminal here, right? Open a new window, new command prompt. Don't go for PowerShell, go for the command prompt, or if you are using map, go for the terminal, right? Here you will need to do uv install or uv add, right, -r requirements .txt. Alright, that will get all the packages that we will need in order to run all the programs. That will bring everything up to date and you can start running. Alright, now let me close this. First step is to install the packages. So we will run this piece of code. This should run perfectly. So it has run. So it took a while for it to complete the entire run, but it got completed. One thing I missed to say is, when we installed the packages, that is using uv add -r requirements.txt, right, .txt. When we did this, this will start a virtual environment. So that will create this particular folder which contains all the packages that is required to run the code. So this is the virtual environment. Now when you run this particular notebook, you will need to select the kernel that you will want to use. So this kernel points to the virtual environment present over here. And for this kernel to work, in order for you to be able to select this kernel, you will have, now this is correctly selected, but before this there will be select kernel option. Once you click that, you will be shown an option to select the kernel present in this directory, .venv/scripts/python something will be there. Alright. In order for that to appear, you need to have started this notebook from, or this session from inside this particular directory. Otherwise, that might not show up. Just a caution so that you will be able to get everything working. So everything is set. Now let's start preparing the data. Here I have prepared 20 questions based on F1 racing. 20 FAQ questions are there, questions and answers. That is all stored under this string which we have stored in this variable called FAQ content. And this function will load up this data. This function which is load FAQ data. So let's run and define that. Next, this function will load up the data or clean and split the data. Right. So initially you had question and then you had the question and then answer in the next line and then you had the answers, right? This one will make it in, instead of having it in two separate lines, it will have it in one single line. Alright, answers will go in the same line and that will be one entry. That's exactly what this piece of code does. Next, we have a helper function that will help us iterate in batches. So given the data, it will help to create iterations where you will have like batch size number of items to be picked up in first iteration and then same size in the next iteration and so on. So that's what this particular function does. Next, we have the embedding generator class. So this is a very important class where the actual embedding happens. So first we initialize the variables. Here we initialize the model name, which is a nomic based embedding model. batch size 32. We initialize the model. This is a function that we will be defining shortly, right? This function. Then we have the empty list to store the embeddings and a list to store the contextual text data also. Then we have the initiate model function. This returns the HuggingFace embedding model. Alright. Then we have a function to convert the text to vectors. This actually does the embedding. We use the model object, pass the text, and this will convert the text into numerical vectors. And finally, we have the function that processes the data and generates the embeddings. So we have text data, it creates the batches, then iterate through the batches, and in each iteration, it converts the text to the vectors and then add it to the embeddings object, which was originally an empty list. Now it will have all the vectors stored inside it. And now that the embeddings are created, we need to now load it up to the vector database. So we are creating a vector database class for this. Alright, so here we have the vector database class. Here it contains certain functions. Initialize will set the initial values for the variables. Then we connect to the database. So this gets us connected, and then we have a helper function to check if a collection exists or not. And if a collection does not exist, so collection exists, we are giving a name to this, right? If it does not exist by that name, it will create a collection. Or if it does exist, it will just print that the collection already exists. And the next step is to actually store the embeddings inside the vector database. And that's exactly what we do here in the store embeddings function. So here it iterates through batches in pairs of, so this gets the text data and we have the embeddings here. It iterates through batches and uploads the collection to the vector DB. And finally, we have some optimizer function to make the searches fast. So finally, we need to create the class to actually do the searches. This is like the retriever. We initialize it with the database that we just created, the vector database, and the embedding generator. Alright, so both of these are classes. We will initialize those classes and then use those and pass those as inputs to this particular smart searcher. And then we finally have the function to do the actual searching, right? So find similar content. This function will actually do the searches. First, we get the embeddings for the user query. Alright, so we have that embedding stored over here. Then we start doing the search. Now inside the database, we specify the collection name, the question vector that we got over here. Then with the search parameters, how many top K results we need to retrieve, and give a timeout also. So this will fetch the search results. And finally, from the search results, we will get the content, right? We will append it to the relevant content object. And then we will use the relevant content object, make it all in one single line, or either format it in multiple lines in this kind of a format and return the final combined answer. Alright, so to summarize what we did, initially we started off with the vector database, right? So first we process the text, use the embeddings generator to create the embeddings for the text. We load it up to we create the vector database and load it up into it. Then this is the part where we load it up to the vector database itself. We are uploading the collection here. Once this is uploaded, we will start the search. For a given user question, we will find the most similar content. This user question will get converted to a questions vector. Using this questions vector, we will search the vector DB to get the top K results, and that we will format to form the final combined answer. So once this is all defined, we have created a function to put it all together. Alright, so load the FAQ data, clean it up, load up the pairs, process the data will actually load up the pairs, and then we will create the vector database collection, the database itself, create the storage space, store the embeddings to the vector database, and finally, we return the searcher object. So this is the retriever of the context. We have another function where we use searcher, we pass in both the searcher and the question. And the searcher will have a function called find similar content, pass in the question, user's question, and that will return the final context as the answer. This is the final function to run everything, right? So the results of running all those steps is getting nicely printed out in this part of code. And finally, we pass in some text example questions. What is slipstreaming? What is hello device? We take these three questions, ask those questions, that is ask question, searcher, and then the question. And this returns the correct answers. For example, if this is the question, what is slipstreaming? the first relevant result that is giving is this particular question. What is slipstreaming in F1? And it has the answer. And since we have given top k equal to 3, it is retrieving top 3 results. Alright, same applies for the other 3 questions also. For every question, we will get top 3 results. So that completes the setup for the entire RAG part. Now, what we need to do next is to set up the web search tool, which is Bright Data. So, go to brightdata.com. You need to create an account if you are going here for the first time. I have already created my account. So, I will go directly to my user dashboard. So, click here. Click on the user dashboard once you have created the account. So, this will load up a dashboard that looks currently like this. Alright. And find account settings here. It's right now it is here. So, I'm clicking on this. And once you are here, you need to add a new user. So, go down, create proxy manager users, click on new users, give an email and password and store both of them. You will need both the email and the password in order to make this work. So, now once you have that, create your .env file if you have not already created. So, create that file and create these 2 entries here. So, Bright Data username and Bright Data password. I'm showing my username and password. I'll go back and change this later, but have your information stored here in this kind of a format. Now, once that is done, we can start creating our server2.py. So, this is the content of server2.py and this is the exact steps we need to do in order to start the MCP server. Alright. So, here we will start by importing the fast MCP object, and back to Python file will have all the classes that we have defined in this particular Python notebook, right? So, this file is present inside the repository also, you can use that directly. Now, this will import all the classes essentially, right? Now, here we create the MCP object, then we will use that to sort of define the tool. So, we need to add this decorator to make the function that we are defining here as a tool that can be used by the MCP client. So, when we started seeing the MCP client here, right? So, when we saw this, if you go to MCP, you have a couple of different tools available here. These tools are nothing but the functions that you are seeing over here. F1 FAQ search tool. Now, to make a function to be available as a MCP tool, you need just 2 things. You need to define this particular decorator. You should have the MCP created here. Alright. So, add this decorator and add a very nice doc string to this. Very clear and nicely described. So, once this is defined, here we have the content of the tool. Here if you scroll down, the first tool defines the exact functions or steps that must be done in order to get the results for a given user query. So, this is the input. The returned response is the response after searching the database. Alright, this is the additional context. This is the additional context after searching from the vector DB. And in a similar sense, we have the Bright Data function. So, here it also takes the query, and what function it does is, it connects to the Bright Data API. So, it has to import all these libraries and then connects to the Bright Data API from here. That is, it is using the username and the password to compose the proxy URL and uses that to make the request. Alright, so here it makes the request. Here is the part where it makes the request. It is requesting this particular URL. It's using the Google search. Additionally, it passes the Bright Data proxies and gets the response. From the response, we get the final result. And finally, we have the function to start the server. Alright. So, once everything is set, so we have defined the function for the Agentic RAG app for the Bright Database search tool. Alright. So, both of these functions are set. Now, the only thing left to do is to define your MCP server. So, click on the gear button on the top. This will bring the settings, and click on the MCP button over here, right? The MCP tab, click on this and you will get this screen. Now, I have already set it up. So, for what you need to do in order to make this setup is, click on this particular button, which is add new global MCP server. This is the exact command that will be run. So, we are calling UV essentially, and this is the location of the UV here. If you are on Linux or Mac, on your terminal write which UV to find the location of this particular file. Alright. In Windows, the location will look something like this. So, this is the profile name, right? This is the user profile. If you type user, all in caps, user profile in your command prompt, right? If you write this, you will get this part of your path. then go inside this /local/bin/uv, make sure this file is present. Alright, then you can add that to command. Then we define the arguments. So this is the main command. We define the directory argument. So this is the location of the project folder here. This folder contains all the files. Right, this folder should contain the server2.py, which is the file that we have here. Right, server2.py. So the command essentially is like this: uv -- directory. Alright, and then you have this whole thing. This whole thing is over here. Then you have run server2.py. Essentially, this is running this particular command in order to start the server, and that's exactly what we are defining here. So once this is defined, go back to your server setting, wait for some time, turn this off and turn this on and do the refresh. This will turn green in some time, and then you will be able to see these two tools. Once these are available, then you know that, okay, your MCP server is currently up and running and you can start using it. Now, in order to start querying, you need to you can go to any particular script. So from here, from your editor, click Command+L or Control+L on your Windows, if you are using Windows, right? And then you will have the chat window, right? Here, remove all the other context here, and then you can start asking the questions. For example, say teams in F1 season. Alright, so we ask this question. Let's see what it does. So it's calling the F1 FAQ search tool. Alright, I'm accepting this. Then it means that it is actually calling this F1 FAQ search tool. Alright, it's taking some time to generate the answer for this. Okay, interestingly, it's also calling the Bright Data web search tool. Now I will give accept to this also. So typically what happens is, this itself will give the result. It will look up this particular line and then it should be giving the result. Okay, I'm unable to access real-time data. There is some problem with the connection in my internet here. Alright, otherwise it usually works fine. Now, this one is not, it's calling the other one. Maybe we will try a different question. So how long is the standard? And create a new chat this time. Click on this one, remove the context and paste the question. Let's ask the same question. It's giving the answer directly. So this can also happen sometimes because it is having access to the large language model, right? So we close this. I'll ask one more time. What is the DRS? Alright, let's try this one. So now it is asking, calling the MCP tool F1 FAQ search tool. Alright, I'm going to accept this again. Let's see if it is able to look it up and get the answer. Okay, so it's giving the answers correctly. So this seems to be working as intended. So if you have any more questions, try to implement it on your own. And if you have more questions around this, please do ask in the comments. I'll try to answer that. Until then, I will have a great time and I will see you in the next one.